Hey guys, it's Crystal, and today we're going to be going over the solution for our advanced problem of the week, which is garbage disposal. So if you haven't read the problem, feel free to read it. I guess you can just read it here, or you can pause the video. So we have basically Vasya hates garbage, and he knows how much garbage he's going to produce a day. He also knows how big his bag is over here, so that's how many pieces of garbage he can hold. Next, we also know how many days Vasya will have garbage. So we have a bunch of test cases here for sample input. Looking at the first one, you can see that Vasya produces 3 pieces of trash the first day, 2 pieces of trash the second day, and 1 piece of trash the third day. And Vasya also, Vasya's trash bag can hold 2 pieces of trash. So you can see that a good solution would maybe possibly be to throw away like 2 bags of trash on the first day, and then like 2 bags of the trash on the second day, 2 bags of trash, or 2 pieces of trash on each day. And then at the end, since 2 pieces of trash is in 1 bag, that'll just be 3 bags of trash at the end. So at first glance, it looks like, oh, maybe you can just look for how much of total trash Vasya is going to produce and just divide it by K. But that does produce a problem since each day you don't know how much Vasya is going to have. Like maybe Vasya will have like a crap ton of trash at the end or something, and then that'll mess up the number. So basically what you have to do is, after thinking about the problem, there is an optimal way to put Vasya's trash in the trash can. So it's better or equal to put Vasya's trash in the trash can on the second day. And that sounds kind of weird. Like, why would you make Vasya wait? But I will prove in a second why it's always better or just equal to throwing it away on the first day. But overall, you should be trying to prioritize throwing the trash in the second day, if that makes sense. So, for example, given our first test case, we have like 3 days, 2 pieces of trash per can, and then you have 3, 2, 1 for each number. So, I guess, I don't know how to draw this. I didn't think about this. Oh well. Here are some cans. First day, these dots are tiny. First day, he has these trashes, whatever. And then second day, he has 2, and then third day is 1. So overall, it never hurts to move your trash to the second day. So for the first day, we could either just throw in if we throw in these 3 and just straight up throw it in on the first day, that's like a person. Okay, anyways, if you throw in the 3 in the first day, you're going to need 2 buckets of trash, because there's, again, 3 pieces of trash, and then 3 divided by 2 rounded up, which is basically how many trash cans you'll need. You'll need 2 trash cans to fit 3 cans of trash if you were to have 3 pieces of trash, if that makes sense. And then the second day, if you just throw it in as soon as you get it, wow, these all look like faces. Okay, sorry. You would need 1, and then the third day you would need 1. And then so that would have a total of 4 trash cans, which, if you remember, is not the optimal solution, because the optimal solution has 3 trash cans. So you will have to find a way to find the most optimal solution every time. So again, I argue that it's always good to hold the trash to the second day. And the reason why this is because you have like your 3 trash on the first day, 2 trash on the second day, and then 1 trash on the first day. Is because if you hold it to the second day, it has a chance to kind of, I guess, mingle with the other trash. So it means that you won't have like extra trash left over. So for example, like on the first day, we threw away this 1 little piece of trash by itself. So our groups were like this and then like this, if that makes sense, because each trash bag can hold 2, but we wasted an entire space in this trash can by just throwing this away on the first day. So instead, if you move it all over, then instead of having this weird thing go on, you'd have 5 here. And then you'd be able to make bags of 2 with this guy and this guy. So then you would have 2 full bags of trash. And then since you want to move things over, you'd move this one here. Then you'd have, so here you'd have 1 bag of trash. Here you have 1 bag of trash. Or here, sorry, here you have 0 bag of trash. Here you have 2 bag of trash. And then here you would have your last bag of trash. So then if you just add all these numbers, then instead of the 4 we had earlier, we actually are at our more optimal solution at 3. So overall, you can see that you want to try to move your trash over to the next day if it's gonna, I guess, be alone. So instead of letting it be alone, you just move it to the next day, and then same thing, just keep going. But also you have to keep in mind, like, your trash might, it can't stay more than 2 days. So to keep track of all that, it's fairly simple. I have code to show it. So basically, all you have to do is just take in the numbers. It's pretty simple. Or keep track of how much trash you have on day 1 and how much trash you have on day 2. And then just act accordingly. So I'll go through my code with a little bit more detail. Or you can pause the video and try to code it yourself without looking at the solution. But if you're stuck or you just want to see the solution, I guess you can watch. So you can keep track of your first 2 days. That's pretty simple. So I'll get into why that's like this later. But it's obvious the first day you just take in the input, I guess. So you can ignore this for now. It's just on the last case. So for every other index in the for loop, you would just go straight to the else statement. So in the else statement, it's a little bit mathy, but it makes sense, I guess. So you see how many pieces of trash that are 2 days old, which means you have to throw it away. And then you see how many are divisible by k, which is basically just saying how many bags can you fill up with the 2-day-old trash. Then you'll add that to the count. And then for your leftover trash, you'll need to throw this away anyways. So to make sure that it's not alone, or to fill up the bag, you can take some of the trash that's been 1 day old and then now put this into the trash as well. So overall, this will be the most optimal solution. And I didn't mention that, but it's this is called a greedy algorithm. So you basically just take all that you can, kind of. It's a weird concept. It's not like an algorithm. It's like a mindset, But yeah, so you just, this is what you do, except for the very last case. So the very last case, even if the trash is 1 day old, you still have to take it out because, I don't know why, actually. Wait, I do know why. Because no garbage should be left after the nth day. So I don't know why he doesn't want garbage then, but that's in the problem. So for that case, you just put all the garbage left over, put it together, and then do the same exact operation. This is all the same stuff. The only difference is that you add together all the trash. So the reason for this is because 1 day can sometimes become negative, I believe. So if it becomes negative, you don't want that to happen. So you just do math.max with 0 and 1 day. So that means if 1 day is negative, then it'll just default to 0. This is a pretty common trick you'll see people do instead of writing if statements or whatever. And overall, this should, you just have to print count, and it should print out your most optimal solution. Another common error probably that I could see people making with this problem is not making your numbers into longs. I'm not sure if these numbers have to be longs, but I know that for sure the count has to be a long, because if you look at the test case, this number is a lot bigger than integer bounds, which I think is 2 to the 10 to the 8, 9. I don't know what it is, but either way, this is too big, so your count has to be bigger than an integer, so that's why you use long. And that's the solution overall. And yeah, have a great week, guys. Thanks for watching.